Okay, so today we're up to lecture 6 now. Welcome back from a hopefully nice long weekend. Hopefully we got a little bit of rest, and now we're ready to start programming again. So we kind of saw on Friday that there is some additional way that we can add functionality to our program. So up until Friday, we'd really been doing all of our stuff in the main function, and we'd been defining things that we want to work with in the main function, and we didn't really have any input from somebody who used our function outside of that. And so we introduced on Friday this notion of command line arguments. Just like you can give arguments to a function, your entire program is itself a function. Main is a function, and you can give arguments to it as you would any other function. And so we saw that you could, when you're typing Java, the name of your class or your file, you could, as well after that, include additional arguments that would be passed to main that you could then go ahead and use. And we've been typing this sort of boilerplate for a long time now, this string args that always came after main. And on Friday we got a chance to really see that what this variable itself means. Args is a variable that holds all of the command line arguments that you pass to it, so that you can then use them and add functionality and interactivity into your program. And so we saw that you can access the elements of args, which is unlike any variable that we've seen up until now. Args is an array, and you can access the elements of an array by using indices. So args, and then open bracket 0 close bracket, so 0 within brackets tells you that you want to access the first argument, the first element of the args array. And an array really is just like a series of boxes or a series of lockers, so to speak, that all have their own numeric index. And each of these lockers or boxes or whatever you want to call them have things they can store inside them. They have types that they can store inside them, just like any other variable. So args is a string array. So each of these boxes in here in args holds a string. And so when I pass in arguments at the command line, for instance, I typed in on Friday, happy, happy, joy, joy, those get stored in args under each index. And then I can go ahead and just by using the index in brackets, I can access the individual elements of that array. And so arrays are generally used when you want an additional sense of organization in your program. Maybe you want to store all of the command line arguments in a single variable and then edit them as necessary. So rather than creating a separate variable for every single, in this case, command line argument, or for other things that you might be working with, let's say you've got a large database of students in a school and you want to do something to those students. Maybe you want to send an email out to every student. Rather than having a different variable for every single student and then calling, say, a send an email function that might send an email to every student, maybe you store all of those students in an array, and then you can loop over that array, and we'll get to looping in more detail today, but you can loop over that array and just for every element, send an email, move to the next one. Send an email, move to the next one. And so you can compactify your program and keep yourself from writing these sort of long strings of arguments. And so we can take a look at how one might actually implement and call that by redoing a little bit of what we did on Friday, but in a little bit more detail. So on Friday, I think we did a command line test. We'll just do more CMD line. And you can call these classes whatever you want if you think I'm being a little pedantic with my long file names, but I will leave it as is so I can be as descriptive as possible. So I'm going to use my usual boilerplate, which is the class, and then inside that class, always stick a main function. And whenever we save this, we always save the file name as the same name as the class name, .java. So this will be more, actually I want to save this inside this directory, more CMD line. And that's right, recapitalization, yes, .java. And I get my syntax highlighting. So now I want to actually show again how I accessed the args variable. So by using the 0th index, and you can sort of see nicely that Sublime goes ahead and colors the index for you. So if you ever don't see the index light up for some reason, you know that there's something wrong with your syntax. By calling this as is, this arg0, this will give me the value that was in that first command line argument that I passed to it. And if you did yesterday's lab, then... Is my mic on? Okay, yeah, it is. I realized I forgot to turn it on, but I guess it must have automatically been on when I put it on. Either that or it's just so smart I could tell. So when you call arg0, you can call and retrieve whatever was inside of it. But of course, if I just do this as is, this gives me no functionality whatsoever. And so I want to print it out to the screen, maybe. And we can get it even fancier. You know, I could just print out the argument as is, or I could say something like argument with a colon, and then concatenate these two together. So it actually just sort of says, like, this is what I'm giving you back. I'm giving you back an argument. And if I go ahead and compile this, and what is my problem? I'm probably not in the right directory. Oh, I am. I probably typed it wrong then. Oh, no, I used Java. I should have used Java. All is right in the world, and then we... Well, so, wow. You can tell it's the first day back. Public instead of print. There we go. So now, I can go to Java, more command line, and so what will happen if I just run this sort of as is? I get an error, because what I'm trying to do here in line 3 is access this arg0 variable, but this arg0 variable doesn't exist, because the way that Java treats this args array, and we'll get to arrays in much more detail in about 3 or 4 weeks in the course, where we'll be defining our own arrays and working with them, but suffice to say, when you pass in this array into main, it creates it of a certain size, and it knows how many command line arguments you gave it, and it only creates the array of that size. If I run the program just like this, what's the size of args? It's 0, because I haven't passed it anything. So if I try to access, so if the size is 0, there are no elements to actually access. And if I try to go to arg0 to access the first element, it's going to give me an error. And so I have to actually supply it something like happy. And then it's fine. Then it spits out exactly what I would expect it to print out. And I could go ahead and do this with 2 command line arguments and change this to, say, args1. Again, if I do this with no arguments, it's going to try to look for arg0, and it's going to spit out the same array index out of bounds exception, because it's saying you're trying to access 0, this 0th element, and it doesn't exist. So, if I add an additional argument, whoops, I didn't compile it. So now if I access the additional one, I get another error. Now it's saying index out of bounds exception, but now it's at 1. It accessed 0, 0 is fine, then it moved on to the next one, went to access 1, but because I only input 1 command line argument, the length of args is only 1, and so there is no second element to access, and so I have to actually give it 2 arguments for it to be happy. So this is kind of obscene, because this means that if I want to create some kind of program and I want a user to use my program, how do I really know what they're doing correctly, whether they're using my program the way that it should be used? If they put in the correct number of command line arguments, then we're going to be happy. But if they don't, the program's going to crash. And if you're using a real program, who knows what that crash could actually do? In this case, it's something nice by just spitting out a simple error that will compile. But if you're in, say, a self-driving car and it crashes, then you're going to run into certainly a bigger error. So it would be nice if there was some way to check if there were actually the right number of arguments, and then tell the user either, yeah, there are the right number of arguments, or run the program correctly if there are the right number of arguments, or if there aren't, flag the user and say, hey, maybe you should try and put in the right number of arguments. This is how you should use this program. The construct that we might use for that would be what? An if statement. So I want some kind of condition where I'm going to test whether or not basically these calls are going to fail or not. And I can do that by figuring out what is the length of this args variable. And we're going to get to objects next week, and we're going to see that you have this whole abstract class of things that you can create in Java where you can give them properties and functions, and they take on behavior of their own. And this is the fundamental basis behind object-oriented programming, which is what Java is. We've been stuck in this imperative programming, which is really more like C++ programming. You could all go out and write C++ programs now. We sort of get to real Java programming next week. But every object in Java has methods, which are functions that you can call, as well as variables, which are properties of that object. And the args, so an array in general is an object. An array is not one of our base types. We saw our base types are short, byte, long, int, double, bool, char, and that's it. And so array is something new that someone else has created, and there's a variable that we can access of that array. So our array in this case is args, is called dot length. So adding a dot lets you sort of peek inside that object, and we saw that with the math class that we could access, say, the sign function. We saw that with the integer class where we could access the parseInt function. This is actually accessing a variable inside of args that's always created whenever you create this array that's the length of it. So if I want the args to be, let's say, not equal to 2, and you can use a not by using an exclamation point along with your equal sign. So if the arg length is not equal to 2, spit something out at the user. Maybe I want to say, give me 2 arguments. Cool. Because I'm angry, I want them to use the program correctly. But if they don't have, or if they have the correct number of arguments, then maybe I want to run the program as it's, and I might include an else statement. And I won't get into it here, but there are actually ways that you could sort of make your program exit automatically if you don't like what they're doing. And I could go ahead and include something on this line which would sort of cause my program to automatically eject, but I don't want to worry about that now. So if I save this and can go ahead and recompile it, and let's say I include no command line arguments this time. It's going to spit something back out at me. Now if I include, say, 1 command line argument, it's still not happy. If I put in, let's say, 3 or 4 command line arguments, it's still not happy. Only when I put in exactly 2 will it then go ahead and run what I'm hoping that it's going to run. So you can use conditions, if statements, to sort of type check your program. You can check whether, at least at the very beginning, the user is giving you what you actually want them to give you. And so, for instance, this would carry over into the prime number theorem lab that you guys did yesterday, where you're expecting an int from the user. And you're trying to do, say, parseInt only if what you got was an int. You could, for instance, include some kind of condition that says, if this thing is not an int, maybe I want to tell the user, hey, stop, hold on, give me an int instead. If you don't, your computer will just crash all over the place. And then, the user will try to use it, they'll just have egg on their face. They'll look silly because they're trying to use it, and your program keeps crashing. So, if statements are sort of a good way to check your program and make sure that it's doing what it is that you want it to do. So, let's get rid of that. Now, let's just assume, for now, I know what I'm doing, so I'm going to put in the right number of arguments and not worry about crashing. But let's say that I want to include lots of command line arguments, and I want to sort of print them all out. As we saw in Scratch, if you find yourself printing, or not just like printing, but just doing lots of the same thing over and over again, if you, for instance, are copying and pasting the same thing over and over again, then there's probably some more efficient way that you can do it. I could either stick this thing into a function, which maybe prints, and maybe just call that function something short, and I could call that function 5 times, or I could introduce something new, something that we haven't really seen, but if you've been looking over the problem set in the lab, you have seen already, and that's loops. So it would be a lot nicer if I could only write this once, but tell the computer to actually loop and print it, say, 5 times, or even better, only print as many arguments as there are. And so for that reason, we have for loops, which we're now going to finally see in sort of an official capacity today. I intentionally introduced it into the lab and mentioned it a little bit week 1 so that when we first see it now, it's not completely foreign. And so now we can really just sort of step through and have a good idea for what's going on. So there are really 3 components to a for loop. And just like if statements, and just like functions, there are curly brackets where you put whatever you want to actually execute over and over again inside of the curly braces. So there are three things. There's an initialization, there's a condition, and there's an update. And these are separated by semicolons. The initialization is something that runs the very first time that your function or your loop runs. So when your program enters the loop, it will do whatever is in the initialization, which a lot of times for us is something like int I equals 0. Because generally when you want a for loop, when you want some kind of looping mechanism, you need something to keep track of how long your loop has been running, how many times your loop has run. That way you can figure out, well, do I want to exit yet? Because maybe I only want to run my loop a certain number of times. I can keep track of this I counter and then exit once I reach a certain value. Maybe I want to do more complex things with my loops that we'll get to in a little bit. But in general, the initialization usually starts with something like int, some variable name, maybe it's I, maybe it's something else, is equal to something. In this case it's 0. Maybe I want to start my counter at 5 for some reason. In the prime number theorem, we started at 1 and 2 in a couple functions. So it doesn't always have to start at 0, but generally if I'm just counting something, we always count from 0, and so we start from 0. The update is how you change that counter. So the update runs after your loop has completed once, when it goes to complete again. It actually runs at the end of the looping iteration. So just before it starts to run a second time, or a third time, or a fourth time, it executes whatever is an update. Initialization only happens once when you enter the loop. Update happens every single time that your loop runs. So I might start my counter at 0, which will only run once, but then on the right, every time I hit the end of my loop, I want to increase my counter. And so you have this I++, which is funky Java syntax for I equals I plus 1. Increment the counter by 1. And then the condition can actually be whatever you want. You can say I less than 10. So keep running and incrementing I until I is equal to 10, or so long as I is less than 10. And once I is equal to 10, then get the heck out of the loop. Then we're done. We don't want to run the loop anymore. You can also have a while loop, which is a slightly different syntax than a for loop. You can actually do everything in a for loop that you can in a while loop and vice versa, but the syntax is slightly different depending on sort of how you want to treat the variables in your program. So whereas in a for loop, you pretty much always explicitly have a counter. You're always initializing something to be something, and then you always have an update which you are incrementing. In a while loop, you basically say, don't worry about the initialization, don't worry about the update. I'm going to do that on my code somewhere within the loop. Just check the condition. And so this while loop is going to, every time it goes to run, check, is that condition true? If it is, it's going to run it. Something will happen inside of your code. When it gets back to the beginning, it'll check, is that condition still true? Now, if you're not doing anything inside your code that's going to eventually make the condition false, then you're going to get an infinite loop and your program will run for all of eternity or until you run out of memory. So you want to do something within the curly brackets which will actually change your function. And what I'm going to do now is reopen the lab that we had done yesterday and then modify it. So save that here. So let me get rid of all this. So I'm not going to run it yet, so I'll maximize this. Okay, so I have pretty much the end. If you had gotten to the end of the lab yesterday, this is pretty much where you are, where I have a main function, which I'm not doing anything, but I created two other functions in lab yesterday. There's this trial division function, which has a very specific behavior. I give it an int, I pass in an int as the argument, and then I get back a Boolean value. That Boolean value tells me, is this thing that I'm passing into it prime or not? My trial division is sort of like a black box. I say, here, take this int, and then give me back true or false. And it goes ahead and it runs through some code, and it tells you whether or not the variable is, in fact, true, or whether or not it's prime or not. And then I took that one step further and had the count primes function, which takes in also an int, but a different int. This int n is not necessarily the same as this int n, because I'm doing something different with it. It's just a number. So this count primes is saying, give me a number, and then count all of the primes from 1 up until that number. So tell me how many primes are less than or equal to that number. And I used a for loop to sort of iterate from 1 to the actual number that I gave it and count all of the primes and only increase my counter if the trial division winds up being true. So now I'm going to sort of take this one step further, and I gave it as sort of a further experimentation hint in the lab assignment, and use a while loop to actually count the nth prime. So let's say now I give it 100. If I give 100 to count primes, it's going to tell me how many prime numbers are less than or equal to 100. But if I say nth prime, what I'm looking for is give me the 100th prime. So only count when you see a prime, and then at the end give me back the number that represents that nth prime. So this is also going to take a number, int, except now, rather than using a for loop, I'm going to use a while loop because the condition is the initialization is going to be slightly different. So in this case, with the while loop, what's the condition that I'm going to check? So okay, fasten up 1 second. In the for loop that I had above, what's the condition that I'm checking? Has my loop reached the nth variable that I gave it? And once it does, go ahead and exit. Well, now it doesn't really. So my counter is not what I necessarily care about. What I care about now is sort of a different kind of counter. Not the number of times my loop has run. I care about how many primes have I seen. And so, whereas in a for loop, this update rule will happen every single time, maybe I don't want that to happen every single time. Maybe I want, I only want the count to increase if something else happens. So, I'll leave the condition for a second. But what do I actually want to do in this loop? I want to sort of count primes. Question?
Your microphone is on.
Is it? Thank you. Is it on now? Okay. Thank you. I think when I went to go try to turn it on, I must have accidentally turned it off. But thank you for the heads up on that. So when you want to go, we're in this nth prime function now, and I apologize if you couldn't hear me and are just rejoining me now after 10 minutes. We have this while loop and we want to calculate the nth prime. So let's start with some variable. Let's call it count. Now this count, first and foremost, is not the same as this count. And I mentioned this on Friday, that when you declare a variable inside of a set of curly braces, that variable only lives, it's only alive inside of that curly braces. And once you go outside of it, no part of your program has any recollection of that variable. So this count is only valid, and I can only call it and use it inside of this function. So likewise, even though I'm creating a variable with the same name, it's actually a completely different variable. These are not conflicting each other. So I want some variable count, and I don't necessarily want to count it or want to increment it every single time the loop runs. When do I want to increment it? When I see a prime number. How do I know that I've seen a prime number? Well, I have this if statement, and I'm basically going to copy over what I had before. If the result of this function being trial division, evaluates to true, then I say, okay, I've seen a prime number. Go ahead and increase the count. What am I passing into trial division? Well, I haven't actually defined that yet. So I do need something that is going to keep track of how many times my loop has run. But because I'm using a while loop, I'm going to take care of that stuff on my own. So rather than putting int I equals 0 in the actual for loop, now I've got to define it on my own outside. And likewise, inside of the loop, I have to take care of the incrementation myself. So I could have actually taken this entire while loop and turned this into a for loop, but to show sort of how a while loop operates, I'm doing this explicitly. So, is my mic off again? This thing is apparently very buggy. I'll try to glance down, and I have a little light on here that tells me whether it's on, so I'll try my best to keep track of it, but thanks. So we have this trial division, and if it evaluates to true, we want to increase the counter. What am I passing to trial division now? I'm passing this counter that I'm keeping track of, this I. This I is always going to increment. So it's basically going to tell me how many numbers have I seen already. Yeah, that might be a problem. I'll try to yell. Now it won't even turn on. Okay, so I only want to increase this count if my trial division evaluates to true. And so what I'm going to pass into trial division is this I counter that's keeping track of how many times my loop has run. Because every time that my while loop runs, this I is going to increase. What I haven't actually covered yet is when do I want my while function to stop? When do I want it to say, okay, I've had enough, you can stop running, you can now get out of here. The point of the program is to count the nth prime. So what I want is to check, is count equal to n? Or in Java terms, only run while the count is less than n. And as I keep incrementing and incrementing the count, as I keep seeing primes, once I finally hit the nth prime, it's going to stop. And it's going to exit the while loop. And then I have to return something from the function. What do I want to return from the function? Do I want to return count? Not necessarily. So count, I already know what count is. Count is going to be equal to n. At least the value of the variable count is going to be equal to n. But that's not the question I was asking. The question I was asking is, what is the nth prime? I.e., what is the value of I when I have hit the nth prime? So I want to return I. And so now I can go up to main and actually use this function, do something with it, by calling nth prime and passing in something. I have to pass in a command line argument. And we did this in the lab yesterday where I showed that you can't just pass in args as it is because that is a string array. I have to turn that into an int because I say down in nth prime, all I'm expecting is an int. This function can only take in an int. It cannot take in anything else. So first, I have to call the integer class with its parseInt function and do that on arg0, which is supposedly the first command line argument, which is the number that I'm getting in. And let's save that as an int called x. And then we'll pass x to our nth prime function. But this by itself isn't going to do anything that I can actually see. So I have to print it to the screen so that I can see what's actually going on inside of that function. And so I will save this. And now I will pull down my Cygwin window. So if I go ahead and compile this, hopefully no errors, at least no compilation errors. We could have a runtime error when I go to actually run this, or even a logical error if I run my program and it doesn't do what I want it to do. But let's see if it actually is going to do what I want it to do. So I'll call this with Java, but then I need to supply a command line argument. If I don't, I'm going to get that same array index out of bounds exception because I'm accessing arg0, but I have to make sure that I'm giving something to arg0. So let's check how many, what is the third prime? And I'm actually going to assume that 1 is a prime number here. There's debate over whether or not it is, but I'm going to assume that it is. So the third prime should be 3. And so after I run it, I get back 3. What's the fifth prime? This should be 7. Right? So if I run this with 5, I'm basically error checking to make sure that my program does what it does. And so far it looks like it's doing what I think it should do. And then we can start experimenting and say, what is the 1000th prime? 7,907. And so this loop down here, this while loop, is actually running 7,907 times, but the condition is not dependent on the counter, it's dependent on this extra variable count that I created. So counter in this case is actually I, and so I'm sorry if I'm misusing some of this terminology and I'm overloading this terminology, but it depends on count. And so for loops are really if your exit condition depends on the variable that's being incremented every time your loop runs. And if it's not, it's good to use something like a while loop. Any questions on that before we move on? All right, so now to sort of take another step in trying to figure out the first problem set. So we've now covered arrays and for loops. Sort of the next little bit that we need to cover is strings, and more appropriately, character arrays. So we've seen arrays of general strings, which is what ours is. We've sort of used strings a little bit in weeks 1 and 2, or 0 and 1, as I've been calling them. Well, a string is an object, and as I've been saying, an object has, so an object is sort of like an interface. The math object, or the math package, has variables and functions that we can access and sort of use for our own good. The string object, or string class, also has objects and functions. And we haven't gotten to any functions on strings except for one, concatenation. Whenever we have a plus with two strings, there's actually something in the string code that says, if you see two strings and you see a plus between them, this is what you need to do. This is explicitly how you take two strings and sort of glue them together. You concatenate them together. So we've sort of seen operations on strings, but we haven't really seen what's been going on underneath the hood. And normally we won't have to worry about manipulating this, but it's sort of a good experiment because we started in day one from this, and sort of the most fundamental unit, and so we still want to kind of lay bare all the pieces that are going on underneath the hood. So in the string class, what's actually happening when you define a string is it's creating an array, and it's sticking a character, which is each letter or symbol, into that part of the array. So for example, if I define a string like Sean, what Java is actually going to do is create a character array, a char array, and it's going to stick a different char within each box. And the size of the array will only be as big as the length of the string. And so there are things that we can do to sort of manipulate chars. And we've seen a lot of ints and doubles and even booleans, which I said were sort of the main types that we're going to be using in Java. The last main type to cover now is this char character. And what does the char really mean? Well, let's go ahead and experiment. So I'm going to create something new here, and we'll call this char test. I'll go back to my usual boilerplate code. And so I want to do something now, just so that I can play around and see what's actually going on when I am dealing with chars. And so I'm going to save this as chartest.java. So, okay, let's say that I passed in an argument at the command line. That argument will always be a string. Java cannot take ints as arguments. It cannot take chars as arguments. It can only take strings as arguments. And so the first thing I have to do if I want to, well actually, you know what, let's make it simple. Let's not use command line arguments. Let's just define our own string. We'll say string name equals char. And so I can turn that into a char array, and I mentioned this slightly in the problem set by using this function called toCharArray. And so this function you attach to the end of your string, which in this case is my variable name, by using a dot. And so just like I used math.sign or integer.parseInt, I can use name, which is the name of my variable. So this is a little bit more confusing, and you might ask, well, why do I use a standard math class, the same math class every time, or the standard integer class every time? But here, I'm not typing string.toCharArray, I'm typing name.toCharArray, and the answer will become a little bit more clear in about a week and a half when we delve more clearly into objects. But for now, suffice to say, this variable itself, because it's of a specific type, string, which is already defined elsewhere, has a bunch of functions inside it, and you call it by actually calling the variable. So this name.toCharArray is going to give me back an array of chars or characters. And so maybe I want to save that into something. I'll call it X for lack of a better name. Is this appropriate as I've written it? Based on what I've seen up here? No. So whenever you define an array, so this char as it is fine. If I wanted to define only a single char, this is good. But this gives me back something different. It gives me back a char array. So I need to add brackets. And you'll do this whenever you want to define an array. And we are going to get to arrays in much more detail in about 3 or 4 weeks. But for now, suffice to say, if I want to define not just a single type, but an array of a specific type, I include brackets after the variable name. So this char x brackets is going to say this thing, x, is going to be an array, and inside each box is going to be a char. And so when I do that, I should be able to unpack it and look at, say, the 0th element. What letter should the 0th element be? Capital S. So let's see if it is. So now this is something new, so Java C char test. I have to go in one floor more. Okay, so I'm compiling it. Remember, always to compile your code and include semicolons. And then I want to run it. Now, I'm not actually accessing arg0, so I don't have to include any command line arguments, so I can just run this as is, and it should do these 3 steps and print out the value of this x0. And it does. It gives me a capital S. So let's sort of tease this apart a little bit. We saw that we could do casting between types in Java. We could turn, say, an int into a double and a double into an int. Well, can we turn the char into something? Let's create a new variable. We'll call it y. I'm declaring it as an int. And I want to access that same 0th element, and actually, so that it's a little, actually no, this is fine. So I want to access the 0th element. What's wrong with this as I've typed it on line 7? The right side is a char, but the left side is an int. So I have to use casting. Now you can cast between primitive types in Java. So that's that very first slide that we saw that listed the basic types. Those are the things you can cast between. I cannot cast between a string and an int because a string is not a primitive type. That's why I need to use an additional function. Likewise, I can't cast between a string and a char because not primitive types. But I can cast between a char and an int. And let's go ahead and see what this actually gives us. So I'll use my system.out.println again. For this time, I'll print out y. So I'm first going to print out a character, which is x0. I'm going to convert that character into an int, call it y, and then print out that y. And what do I get if I do that? Well, I get s, and then I get 83. What does that mean? Why would this character s have this value 83 as an int? Does anybody remember? ASCII. You can just yell it out. ASCII. Yes. So if you actually go to, it should be ASCIItable.com. And I'll put this link on the website. I don't think it's up there yet. You can see on the very first page listing of all of the various ASCII values. So don't worry about this hex and oct. But decimal is the integer value that we're used to using, and then char tells you the associated character. And so I can see as I go down, you have some kind of cryptic characters, and this actually tells you what those things mean. But if I go over to 83, which is what it told me the value of s was, I can see here's 83. I have a nice pen for this. So here's 83. Which is not working, but here is 83, and then here is capital S. So there's a nice mapping between characters and int, and I can sort of convert back and forth between them. And in addition, I could do other things. So let's say instead of just casting x0 as an int, maybe I want to do something like add 1 to it. Can I do this? No. The reason that I can't do this is because of my parentheses. On the left, I have a char. On the right, I have an int. And you can't explicitly add an int to a char. So this is actually no good. But what I can do, after I've converted this into an int, I'll create a new variable, call it z. And I'll add y, whatever that value is, which in this case would be 83. And I'll add 1 to it. And then instead of printing out z, let's go ahead and actually cast it back to a char. So I just sort of shoved this whole thing directly into println instead of storing it in another variable, which I could have done. But so we can see what's going on here. We know this y should give us 83 once it casts from a char back to an int. if I add 1 to it, we know what Z is going to give us, 84. What's the character that's likely to be associated with 84? Capital T. If there's any kind of logic to this, and one would hope that lest we all go crazy, there actually is some logic to it. So let's see if I get back an 83 when I run this. Thank you. Luckily for me, my compiler is also just as smart. Okay, so char test, this is fine because I don't need command line arguments. And so I get S, and then I do in fact get T. So I can sort of use math, and I can shift numbers around by casting them from chars to ints and back to chars. Hint, hint, wink, wink. So hopefully some things should become a little bit clearer. Is there a question or are you stretching? Okay. So hopefully things are a little bit clearer. One thing that I did want to mention, that I'll be changing the problem set tonight that I didn't actually make clear. So some of you may have already gone ahead and banged out your problem sets, and it may have seemed really easy, but there's a little thing that you'll have to add that will make it a little bit trickier. So what I didn't explicitly include, and I'm actually going to mention the problem set itself in more detail, and cryptography in more detail on Friday, but for now, if you looked over the problem set, you sort of have an idea of what you need to do. What I didn't mention was that if you're shifting, and your shift takes you past the end of the alphabet, so you're shifting, say, past Z, you do have to cycle back around and add back onto the beginning. So it's sort of circular in that sense. If you have Y and you want to add 2 to it, you should get back A. Because if you shift 1, you'll go to Z. If you shift 1 more, you'll go back to A. A few additional stipulations, again, these will be made explicit when I change the problem set today. Capital letters should stay as capital letters. Lowercase letters should stay as lowercase letters, so you're going to have to figure out ways to check for these. In addition, spaces should stay as spaces. You shouldn't shift those at all. And question marks should stay as question marks. So your program will need a way of figuring out what character it is that you're trying to shift, and then doing the appropriate behavior with it. Are there any last-minute questions before we break today? Because we covered a lot today. Question? You could go ahead, and that could be an above and beyond if you wanted to include all punctuation or all non-letters. That's you can include as long as you document it. But for now, I'm going to be a little bit easier and say just worry about the spaces and the question marks. Question?
Do we know how many words we have to decipher?
No. So, okay, so you'll only have one command line argument that could be multiple words. So you shouldn't take in each word as its own command line argument. You should take in one argument that has quotes around it that contains your entire word. So you're sort of treating the entire string of all of the words, including the spaces, as a single message. So you should be breaking it down into individual words. Question?
Are we assuming that spaces have been spaces?
No. So in this case, because you're enclosing things in quotes, and I haven't really gotten to escape characters by that terminology, but we've seen this a little bit in working with our past, that at the command line, you have to sort of escape the space so that the command line knows that there's a space there. Alternatively, if you're using quotes, you do not have to escape the space. You will actually, if you're using a space occasionally in other things, but we'll get to that later. But for now, try it yourself. Take in a command line argument that has spaces with quotes and try to just print it as is, and you'll see you don't need an escape character for that to recognize the space. Any other questions? And I will leave you with that. I'll have office hours today from 3 to 5 in E404 again. Otherwise, I will see you guys on Friday where things regarding the problem set will become even more clear than they are now.